Wait, we can drop into concept physics?
So far.
I'm pretty sure you
Most of
can.
the time we don't.
That means I could have been getting
It's
used.
normally on Wednesday, Thursday.
Yeah, but then it doesn't look quite as good on the college transcript.
That's what they say about everything.
Only if you're on Tuesday.
Especially if you're in honors math, right?
Yeah.
Concept
Concept physics.
Wow, you could all be getting 100% in concept physics.
So actually, we chose the right class to take because period 3 only had like 3 questions. You guys have 5.
They gotta do bad on the quiz then.
What does that mean? Number 4. Find the constant term. Now, first of all, period 3, they don't even know what a constant term is. Same thing with period 4. A constant term is a term that's only a constant. There's no variables in it. Here, for example, let's say you have a cubic polynomial, 2x cubed plus 3x squared plus 5x plus 7. What's the constant term? Yeah, 7. The constant term, the linear term, the quadratic term, the cubic term, right? It doesn't have any variables in it. So if I were to expand this, how many terms would there be? Oh my goodness. There would be 10 terms. One of them doesn't have any x's in it. Which one is that? No, Moose Breath. Well, yeah, if this was just a number, it would be the last one, but it had the oops. Now, every term is going to be 9, choose something, right? A to the something, B to the something, correct? And the 2 powers have to add up to 9, so you have to figure out what combination that adds up to 9 will make all the x's cancel out. Yeah, it would be 3 and 6. Because if you put a 3 here, when you multiply the exponents, won't you get x to the 6 over here? And then won't you get an x to the 6 in the denominator here? And then they can cancel out, and they're not going to have any x's anymore. Therefore, that's the constant term. And then remember, whatever number's up there, that's the same number on the bottom there, right? Make sure you know this pattern for the quiz on Thursday, I guess, for you guys. That number there is the same as that number, and the 2 numbers got to add up to that number. That's the pattern. And then you can take it from here, right? I hope. Because those are just numbers left, right? Okay, and then number 5. How come get so many going on? And then number 6. See? Never mind. 5C. Are you kidding me? Oh man. 1. Okay, now when it's minus, just write 1 plus. Because we're just used to a plus b to a power. So a plus. So if you have 1 minus x, what do you think I'm going to put? 1 plus negative x to the, is that negative 1/3? What does that say? Negative 1/3. Okay, here we go. Did we memorize the binomial theorem yet, or you just wait till Thursday morning? You didn't answer the question, wait. A to the n plus n. How many terms are we writing? What does it say? 4 terms. N. A to the n minus 1, so the power of a goes down by 1. And then now the power of negative x goes up by 1. Plus n times n minus 1 over 2 factorial. The power of a goes down by 1, the power of b goes up by 1. And then n minus 1, n minus 2, all over 3 factorial. The power of a goes down by 1, down by 1, down by 1. The power of b goes up by 1. That's the binomial theorem. And there you go. You guys can simplify that. Now, you guys can take it from here, right? That's just multiplying numbers together. Yeah, but they're fractions, Mr. Park. Well, you better practice your fractions because you're going to get this on the quiz and the test. Okay, D. So you're telling me that, judging from just that minus in between is throwing you guys off? That's what it looks like to me. What do you mean you flip it? I'll flip something. Okay, so a plus b to the negative 1. So do the same thing again. Okay, let's start it over here so we don't run around. So what's the first term gonna be? This is A and this is B. A to the n plus n. Then the power of A goes down by 1. Now the power of B starts going up by 1, right? And then you got n minus 1 over 2 factorial. The power of A goes down by 1. The power of B goes up by 1. And then you get n minus 1, n minus 2 over 3 factorial. The power of A goes down by 1. The power of B goes up by 1. And it's easy because look, when you have 3 factorial in the bottom, then you're gonna have 3 things on the top. That's like the choose thing that we learned, right? It's exactly the same thing, except different. And then you guys can take it from there, right? And to simplify it. And then E, okay, here we go. We need some room here. Use the result from 5D or use long division. So you got 2 choices. How many people did long division? 1 person. Just like the other class, only 1 person. So the rest of you did binomial theorem? Use the result from 5D? What? Yeah, that's right. Okay, look. 5e. 1 plus x over 1 minus x. Isn't that the same thing as 1 plus x times 1 minus x to the negative 1? Negative 1 power means 1 over, right? So isn't this the same thing as this? Yeah, and didn't we do this in problem 5d? Look, 1 minus x to the negative 1. So all you have to do is take your answer from 5d and substitute it in right here. So we got 1 plus x, and what was the answer from problem 5d? Let me look at the bottom. 1 plus x squared plus x cubed plus dot dot dot. See how that simplifies so nicely? Anyway, do we remember how to multiply polynomials? You take the first term, distribute it. Take the second term, distribute it. Go! 1 plus x squared plus x cubed plus dot dot dot. Take the x and distribute it. X plus x squared plus x cubed plus dot dot dot. Add up the like terms. Final answer, survey says 1 plus 2x plus 2x squared plus 2x cubed plus dot dot dot. Now the other method, how come I hear furiously scribbling? You guys didn't even attempt it? Strike 1! Now the other thing says use long division. Well, what does this bar mean when you have a fraction? What does the fraction bar mean? Divided by. So another way to do the problem would be to go 1 plus x divided by 1 minus x. And just do long division like we learned. 1 goes into 1 how many times? 1. Now multiply that times the divisor. Subtract. What? No. 2x. 1 goes into 2x how many times? 2x. And then multiply that times the divisor. 2x minus 2x squared. Subtract. 2x squared. 1 goes into 2x squared how many times? 2x squared. Multiply that times the divisor. 2x squared minus... I see a pattern! 1 goes into that how many times? 2x cubed, and you can see what's going to happen, right? Just keeps going on. But you only have to write 4 terms, so that's it. So which way do you like better? Binomial theorem way or long division?
Binomial is quicker if there's other more complex stuff.
Binomial is quicker.
If you change
I
the
don't
numbers.
know.
I don't know.
Okay, whatever. And then number 6. Didn't we do this last week?
I think we did.
Yeah, I know, but obviously people don't remember. Strike 2! Okay, number 6. It's approximate the square root of 2 by using the first 4 terms of the result in problem 5a. So here's problem 5a. 1 plus x to the 1/2. Okay, I'll tell you right now, this problem's on the quiz. Except that might not be a 1. What could it be?
Q.
No, think. No, think.
3.
Negative.
No! Okay, gosh. Okay, anyway, what was the answer for 5a? Let me look at the bottom. 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed minus dot dot dot. It's actually minus dot 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 because that's the pattern. Anyway, what number do I have to plug in for x to get the square root of 2? 1, right? Because 1 plus 1 is 2. 2 to the half is square root of 2, right? So the square root of 2 is equal to, so all you have to do is plug in 1 wherever you see x. Or is that too difficult? Plug in 1 wherever you see x. 1 plus 1/2 minus 1/8 plus 1/16. And we're just going to make an approximation, so it's approximately that. And then all you got to do is add up those numbers. Okay, so how do you add numbers together? You make add fractions, make a least common denominator. 16 plus 8 minus 2 plus 1, which is 23 over 16. So this would be an estimate of the square root of 2. If you want a better estimate, then you add more terms. The more terms you add up, the closer you get to the actual number. Now, how close is this to the actual answer? You guys know how to compute percent error, right?
6%.
What? 1.6%. Okay, now I only put 1 decimal place. You need to give 3 on the homework if you want credit. I just put 1 because I don't want to give it all away because I need something to correct them. Some of you just think, oh, Mr. Park, you're not going to correct it. You're just going to roll the dice. I need something to correct. Anyway, so now that you saw how the problem went, you might not get a 1 on your quiz. What number would I give? Okay, what did I hear so far? 2, 3, and a fraction? No.
Whatever x.
No, it's a number. It's got to be a number. No! Okay, look at problem 5a and look how you did it. In order for you to do that problem without a calculator, that first number got to be like 1 or... There, you were 4. Why 4? Because you can raise it to the 1/2 power or the -1/2 power or the -3/2 power, right? But now that I told you 4, I'm going to use 9. Now that I told you 9, I'm going to use 16. Now that I told you 16, it's going to be 25. Now since I told you 25, I'm going to go back to 1. You get it? Because if you look at your work in problem 5a, don't you have to raise those numbers to like the -1/2, the -3/2? Yeah, so that's why they got to be square numbers. Unless I give you 1/3 power, then I'm going to give you cube numbers like 1, 8, 27, or 64. But now that I told you that, I'm going to give 1/4 power, 1, 16, and so forth. Yes.
I'm confused on number 1 and 2. How do you know when it's like negative or not?
When there's a minus in between? Because we know the binomial theorem is a plus b to a power, right? So like in number 1, this is like this. You mean that's all it takes for me to confuse you?
No, but then like...
Look, do this then. See, then you get a plus b. B is just negative now, right? So we're trying to find the 6th term, so it's going to be 8 choose. If I'm trying to find the 6th term, 8 choose 5, a to the something, b to the something, but that thing got to be the same as that, and the 2 powers got to add up to 8, so there you go, right?
So for number 2, since it's y to the 3rd, that would...
Negative y to the 3rd is b.
So then y to the 3rd would be negative, and then the negative, so that
Okay,
would...
I don't know what you're talking about. There. So here, a plus b to the nth power, right? It says write the last 3 terms. Okay, so what is the last term going to be? 20, choose 20, right? A to the something, b to the something. But then this one's going to be 0 and 20 then, right? Because that number got to be the same as that number, and the 2 got to add up to 20. Okay, that's the last term. That's the 21st term. What's the term before this going to be? 20 choose 19, a to the 1st, and then going to be b to the 19th, right? And then the term before this will be 20 choose 18, a to the 2nd, b to the 18th. all that means is b is negative. But then when you raise it to an even power, it's going to become positive, right?
Okay.
So what was the question?
For, wait. So for the 20th term, because it's.
This is the 20th term.
Yeah, because it's,
So it's going to be negative.
because it's y to the third.
No, because negative.
Oh,
When you raise a negative number to an odd power, you get negative, right?
okay.
So that's why that term's negative. So basically, if there's a minus in the middle, all the the ones with the odd power are going to be minus.
Okay.
And so basically it alternates. Yeah,
Okay.
yeah, so just make b negative and then just compute it the same way you always do.
Okay.
See, because you know what did you guys do last year? Just memorize. Oh, if it's minus, they're going to alternate signs like that. But don't even think about that. Just make b negative, and if it comes out negative, it comes out negative. If it comes out positive, it comes out positive. Because if you try to think of all these special cases, and then you just got to memorize more stuff. You try to what do you call that? Try to generalize, unify. That's why I'm trying to teach you how it all fits together.
So I shouldn't even look at the negative y. I should just look at the power to see if it's even or odd.
Yeah, so here, a negative thing, negative to an odd power will be
Okay.
negative.
Okay,
Yeah,
I see.
yeah.
Thank you.
Okay, now today's lesson, this is the easiest of the three things we're learning. Solving inequalities. Now even period 3, yes you period 3, even period 3, they remembered stuff, which is quite amazing actually. Okay, how would you solve an inequality like this? X squared is plus 2 is less than 3x. How do you solve, what's the general procedure for solving inequalities? Make one side, Jiro, Chenji, Kigaida. And then what do you do with the left side? You factor it. So your goal, this is your goal. Make one side 0 and the other side you factor. So it's kind of like solving an equation except there's an inequality instead of an equation. So what is this? X minus 1, x minus 2? Did I do that correctly? Yes, I'm the teacher. And then what do? What's the next step if you're solving an inequality? Period 3, remember. You make a number line. You guys remember doing number lines last year? This is the standard way of solving inequality. So what do I put on the number line? The zeros, 1 and 2. Now are 1 and 2 part of the solution or not part of the solution? They're not part of the solution, so you put open circles, right? Make sure you do this because I'm telling you, because if you get the wrong thing, open circle instead of a dot, then you're going to get -1 for each mistake and then they all add up. Because this, like I said, probably besides the logic test, this is going to be the easiest test. Okay, then you have 3 regions to test. Think of a number bigger than 2. 3, plug it in. 3 minus 1, positive. 3 minus 2, positive. Positive times positive is positive. Does this sound familiar? Okay, think of a number between 1 and 2.
1.5.
Okay, 1.5. 1.5 minus 1, positive. 1.5 minus 2, negative. Positive times negative is negative. Think of a number smaller than 1. 0. 0 minus 1, negative. 0 minus 2, negative. Negative times negative is positive. And since we're looking for less than 0, what am I looking for? The pluses or the minus? Yeah, the minus. Less than 0 means negative. Greater than 0 means positive. So we're looking for the minus sign. So shade that in. That's your answer right there. So you can either write x's between 1 and 2, like that, or you can write interval notation. Period 3 just said that's the way your book did it last year. Interval notation. But I don't care. They're both correct. And then of course, okay, let's look at another one. What if you had this? X plus 3, x minus 1, x minus 4, all over x plus 1, x minus 2, less than or equal to 0, but let's put some even powers on here. How about that one, and what the heck, put a cube on this one. Put some powers on it. Okay, so to solve an inequality, make one side 0. It is. You factor this side. It is. So you really don't have to do any work. The hardest part of the problem is to factor this side. So you know you're going to use synthetic division, right? Okay, so you make the number line. What goes on the number line? The zeros of the numerator and denominator. So in order from left to right, what? -3. What? -1, 1, 2, and 4. The zeros of both the numerator and denominator now. Okay, so is -3 part of the solution? If I plug in -3, does it come out true or false? True. What about -1?
No.
False. That's because it makes the denominator 0, which is undefined. So therefore, how can it be part of the solution? What about 1? Yes, because if you plug in 1, you can get 0. Is 0 less than or equal to 0? Yes. What about 2? No. What about 4? Yes. Okay, now we have what? 4. We've got 6 regions to test. However, we learned a pattern last year, right? Okay, now, the pattern is, once you figure out one of the regions, you can figure out all the rest by just looking at the powers. And it doesn't matter what region you like to do. Some people like to do this one because it has 0. Like, I don't know, some people think it's easy to plug in 0. But you know what? I like to use this one. Because when you plug in a number bigger than 4, look, positive, 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 positive. They're all positive and it's positive. That's why I like the one on the far right. But it's up to you. You can pick any one you want. Now watch this. See if you remember this from last year. 4 came from this factor. It has an odd power, so it changes. Because odd power, right? Because that means the graph goes through, so it changes, right? Whereas if you had an even power, the graph bounces off, then it stays the same, right? Okay, so 2 came from this factor, even power, so it can stay the same. 1 came from this factor, even power, stay the same. -1 came from this factor, odd power, change. -3 came from this factor, odd power, change. Does that look familiar? Anyway, if you cannot remember this on a test, no problem. Just plug in a number here, plug in a number, just keep plugging in numbers, right? You can get the same thing, but except this is a shortcut. And we're looking for less than or equal to 0, so which ones do I shade in? The -1, so here, 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 here. Okay, so how do I write that? X is less than or equal to -3, or -1 is less than X is less than 2, or 2 is less than X is less than 4, including 4, so or equal to. Or, what was that? Okay, I can't, there's too much mumbling. Okay, what about over here? -infinity to -3, including 3, union -1 to 2, union 2 to 4, bracket. You guys know bracket means it includes the point in parentheses, it doesn't include, right? I don't care which way you write it. So that's how you solve inequalities. Easy, yeah? And of course, the reason for this is, like I told you, because of the graph. Just like over here, instead of making the number line, if you wanted to, is just think of what this graph looks like. What is that graph? It's a parabola opening up. The x-intercepts are 1 and 2. So where is this graph less than 0? In other words, below the x-axis. Between 1 and 2, right? Look, it's above, below, above. That's why plus minus plus. Okay, so if I factor it for you, like most of the problems on tonight's homework, you're going to find that it's already factored for you. Easy! Okay, but what if it's not factored like this? What if it's x plus 1 over x minus 1 is less than or equal to 3, say. Okay, solve this inequality. Okay, this is what period 3 said. Multiply both sides by x minus 1. If you ever did that on a quiz or test, that's a fatal error. Right? How come I can't multiply both sides by x minus 1? Because sometimes it's positive and sometimes it's negative, right? Doesn't it make a difference with an inequality? If you multiply both sides by a positive or negative number? So you can't do that. Unless you make two cases, which makes the problem way more complicated than it should be, but I don't think you want to. Or you could be clever, multiply both sides by, how come period 3 got this? You could multiply both sides by x minus 1 squared. Because you know that's going to be positive, right? Because it's squared. Okay, but I don't like to do that. I'll show you what I do. I just do what I always do. Make one side 0, change it, kikaida. You know, when you solve inequalities, just do the same thing every time. Just make one side 0 and factor. Now, how the heck do I factor the left side?
X minus 1 over x minus 1.
What? When you subtract fractions, you need to make a least common denominator. What goes on the top? X plus 1 minus 3 times x minus 1. And please put the parentheses here every year. That's the most common mistake of this test. They forget to put the parentheses, and so they make a mistake, which is fine. That's a 2-point error. But then the problem becomes easier than the original problem. Therefore, you cannot get that much partial credit. See, that's the rule. That's how we grade on the AP exam. If you make a mistake and the problem becomes easier than the original problem, you hardly get any partial credit. But if you make a mistake and the problem is at least as difficult as the original problem, then you get partial credit. If you finish it, though. Okay, so what's the next step? Simplify the numerator. Multiply it out. X plus 1 minus 3x plus 3. See, if you don't distribute that minus 3, it's a whole different problem. And so you get negative 2x plus 4 all over x minus 1 is less than or equal to 0. Now, you don't have to do this, but I like to do this. Like right now, if you want to, you can make a number line. Watch what I do though. What did I just do? I divided both sides by negative 2. Make the number smaller, but then remember when you divide both sides by a negative number, you got to change the less than to greater than. Yeah? Is that going to be a problem? See, but look how nice that is compared to that. I don't like when the first term's negative. Okay, what goes on the number line? See, now it's all factored. 1 and 2. 1 is not part of the solution, but 2 is. And without even doing any work, how do I know it's going to go plus minus plus? What did I just teach you? Because this one, if the leading coefficients are positive, you know it's going to be positive because when you plug in a number bigger than 2, it's positive over positive, which is positive. And then they both have odd powers, so you know it's going to change signs. Anyway, like I said, if you don't know anything, plug in a number here, plug in a number there, plug in a number there, you're going to get the same result. And we're looking for greater than or equal to 0, so is that the pluses or the minus? That's the pluses, so that's here and here. So when you write your final answer, you can get x is less than 1, or x is greater than or equal to 2. Or you can write interval notation, negative infinity to 1, union 2 to infinity, including the 2, so bracket. You guys know or, right? Or and union mean the same thing, except we use or between two statements. We use the union sign between two sets. They mean the same thing though. So if you wanted to, instead of writing this or, you could write the logic or, because that's what it means. These are two statements. But you cannot use it here because these are two sets, so you gotta use the union sign. Okay, and that's it. So tonight's homework, easy. Okay, and then looking at the homework, I think, last thing. So we know how to solve any equation on our calculator. So if you can solve any equation, you can solve any inequality on your calculator, right? Oh gosh. Okay, like, what if I ask you to solve this? X cubed minus 6x squared plus 11x is less than or equal to 5. Now let's just go less than 5. How do you solve any equation on your calculator? Make one side 0, change it, keep kaida. Now tonight's homework, if there's no calculator, that means you can factor it, that means you gotta do synthetic division. But if I let you use a calculator, you do this, make one side 0, what do you do now? You graph this on your calculator. So if you were to graph this on, in fact, why don't we practice on your Pocket Cast on your iPad? So go on to Pocket Cast, do a new entry, select plot, type this in. You don't even have to punch in y equal here, like you just punch this in. But then you gotta punch it in like this, you know. X raised to the third minus 6 times x raised to the second plus 11 times x minus 5. You have to punch it in like that on your Pocket Cast. And then you should see a graph that looks like this. Well, I'm just guessing, but that's what I think it's going to be. Oh, are you sure? Oh, so it doesn't look like that. Boo! It looks like this. Okay, anyway, we're looking for less than 0. That means where is the graph below the x-axis? So you have to calculate this x-intercept over here. But see, on the Pocket Cast, it's easy. Just do this. So what is that x-intercept? 0.675. So this is 0.675. Round, always round to 3 places. So tell me, where is the graph below the x-axis? When x is less than 0.675, or you can write from negative infinity to 0.675. Woo! Yeah. So, and this is an important skill in calculus, you know. You have to be able to solve any equation or inequality on your calculator. It's easy. Just make one side 0, graph it, and look at the graph. Right? See, but lots of times though, you don't have your calculator, right? Like if you're in a Turkish prison, you don't have a calculator, so you gotta do this. You gotta factor it and test the number. Okay, so tonight's homework easy. Now tomorrow we do absolute value. That's usually the hardest section. Do you guys know, what do you guys know about absolute value? Just tell me what you know. This is what period 3 said. Oh, just make it positive.
Distance from 0.
No, that's the baby. When you first learn that, maybe your teacher taught you that. It's the distance from 0, but then you cannot do any high-level problems with that. Anybody?
X squared of x squared.
The square root of x squared. Well, that's what it's equal to, but what is it though? What is the absolute value of x? Anybody? It's a... Never mind, just be here. It's a piecewise function. What's a piecewise function?
Oh, it's the
What's a function?
function of different parts.
Does this look familiar? Absolute value of x is equal to x when x is greater than or equal to 0, but it's equal to negative x when x is less than 0. We call that a piecewise function. Does that look familiar from last year? So is that all you know then? The other class said something about a thermostat. I don't know what that means, but who taught you that? Takeyesu or Ruba? So what about the thermostat?
So
If it's hot, turn it down. If it's cold, turn it up.
so it only changes the value if it reaches a certain point.
Okay, stop listening already. Just be here tomorrow then, if you want to learn it. Hey, we finished a little bit early today. That's pretty good.